Okay, so why don't we'll get started. I'd like to get everybody's attention. And so my name is Greg Dearline from Stanford University, and I'll be moderating this next session, which the title of this session, we're looking at emerging technologies. This morning we heard four fabulous talks looking at kind of the future of PBE, kind of with an engineering focus on it. In this session here, we're actually going to hear two talks from kind of the earth science community. One's going to be looking at kind of accelerometers, other kind of sensors about sensing what's happening in the earth and looking at real-time signals, earthquake early warning, topics like that. The other is going to be an earth scientist with NASA JPL looking at what we see from satellites, from kind of INSAR, aperture radar type kind of imaging. And then we'll round it out with Brian Strong, who's the Chief Resilience Officer from the city of San Francisco, kind of thinking about how everything we're talking about here, the performance-based engineering, these other technologies kind of affect what we do. In introducing the first two talks, kind of from the earth science community, I'm real curious myself about the different technologies they're employing and what they're learning from it, these different ways to kind of, again, interrogate strong motion, or interrogate the earth through various types of seismic sensors, strong motion and so forth, and then also from satellites. And one thing too, we have three talks, which is going to allow time for a panel session. I'll invite we'll hold any questions between talks. We'll hold on those, and then we'll have a panel discussion coming back. So I'd ask the audience to really kind of listen carefully, think about what questions you have for the speakers, but also as you listen to what they're saying and follow from what Saeed Saidi talked about this morning, using your imagination, and Ron Klemenczyk, to think about what we're seeing from the earth scientists, the type of data that can be collected, both from various types of sensors. These data sets are really getting massive. They're being made available in more real time increasingly, and also from satellites. So to think about how the earth scientists are using those data to inform their science and how that impacts us, but also how the types of sensors they're using, how that data can be used in new and different ways, especially as we kind of go to the future. So if you just kind of keep that in mind as you listen to the talks today. So our first talk up, I'll welcome up Richard Allen, who's the director of the Seismological Lab here at Berkeley. His talk is going to be focusing on earthquake early warning, distributed sensor networks. But Richard's really been active in kind of promoting and leading the development of a number of things like Shake Alert, MyShake. In case you don't already have that, you could look it up on whatever app store you buy for MyShake. So I'll let Richard tell us about those things, but really delighted to have you here today.
Great. Thanks, Greg. Well, thanks, Greg, and thanks to the peer community for inviting me to come and talk about this. Greg was saying in his introduction about thinking about how these technologies might be used, and we're very much at a point with the MyShake project, as I'll explain, of trying to figure out, where the data that we're just starting to collect could really be most useful. And I suspect that there's lots of use cases within the engineering community that, as earth scientists, we're never as well connected to that community as we would like to be. So I very much look forward to hearing ideas on how this might be useful for your communities. Okay, so I'm going to talk about the MyShake project, which is a smartphone-based project that really has two elements, and so I'm going to talk about both of the elements to it. The first element is earthquake early warning, and I'm going to talk about the earthquake early warning aspects. And then the other piece is the whole idea of distributed sensing networks and using the accelerometer in your phone to collect seismic data. In all of the buildings that we've been hearing about, we could potentially be collecting seismic data in those buildings using the phones that are already there. So that's where we're going to go. And as Greg said, if you don't have the MyShake app on your phone and you work in seismology, shame on you. You should download it right now. It won't cost you a penny. Okay, so I'm going to start by talking about earthquake early warning. I don't really need to introduce what early warning is to this community, but just to give a little context for this. The idea with earthquake early warning is that it takes a significant amount of time between when an earthquake starts and when the earthquake is doing its damage. And so this is a cartoon, obviously, but it's a real-time representation of what is probably the most damaging earthquake for us here in the San Francisco Bay Area. It's a magnitude 8 earthquake on the San Andreas Fault that is rupturing from the north down towards the Bay Area. And so this is the rupture that started when I started talking about this. And then it's just representing P waves as yellow circles that are radiating off it periodically, and S waves as red circles. So right about now is when we would actually know that there was an earthquake going on right here in Berkeley. We would feel the shake. We're all fairly well trained, so we would probably, after about 3 or 4 seconds of shaking, know that this was a pretty scary earthquake. But for most people, they wouldn't really understand what was going on. They wouldn't know what kind of earthquake it was. Of course, it's not until the S wave, the first S wave, arrives here in Berkeley that the really strong shaking would start, and that's right about now. We're about a minute into the earthquake at this particular point. But still, the really strong shaking from this earthquake, of course, isn't going to arrive until the rupture itself actually makes its way all the way down through the Bay Area and radiates its energy very close to us, and that's when the most damaging ground shaking is going to occur. And so the point with earthquake early warning is we want to detect the earthquake when it begins up here, and we want to provide a warning to people out ahead of the ground shaking. And there can be seconds, tens of seconds in a scenario like this. There could potentially be a minute or so's warning. Now there are still many challenges here. Just how quickly can we tell how big the earthquake is going to be is the key challenge. And so there are definitely scientific questions we're still working on to better improve or to improve the performance of early warning in the future. But the point is, as you probably already know, earthquake early warning is already here today. If you have the MyShake app on your phone, you would actually get a warning. So what are the uses of earthquake early warning? Why is earthquake early warning useful? And I'm going to show this video that I would suspect many of you have already seen. This, of course, is a video from Mexico City from the earthquake a couple of years ago, more than 2 years ago now. The point is that Mexico City has an earthquake early warning system. So I'll play the video. So that siren that you can hear in the background, that is the early warning system. The reason that these people are in the street is because they got the early warning signal. So this is an obvious use case for earthquake early warning, and I think that this really demonstrates the value, the potential value of earthquake early warning. In this case, Mexico City. It's interesting for me as a seismologist to point out to other seismologists that, of course, buildings don't just collapse as soon as the S wave reaches a building. It takes some time, as we saw in this particular video. But this illustrates just one of the use cases for earthquake early warning. And where I'm going with this is that the goal of the MyShake project is to deliver earthquake early warning around the globe. And the reason for that is that with the MyShake project, the idea is to not only deliver early warning, which we're doing today in California, but it's also to detect the earthquakes and provide the early warning. So that's the real motivation for us behind the MyShake project, is to detect earthquakes with our global sensor network and then provide earthquake early warning to people around the globe. Okay, so this is what we call the MyShake platform. It's evolved into a platform that's trying to facilitate the delivery and the development of earthquake early warning in different environments. And so any early warning system, of course, has to have some kind of sensor network. What I'm showing here is a combination of phone-type sensors and then the traditional type sensors. And the MyShake platform is designed to use data from both of those sources. There then, of course, has to be some sort of decision-maker process that decides when to push out an alert, and then pushing out the alert, sort of geo-targeted alerts. You have to know where the shaking is going to be and push out the alert to those regions. And the idea behind MyShake is that if we can do all of this process with smartphones, then at this point we can pretty much do this anywhere in the world where there are people, because there are essentially smartphones wherever there are people at this point, and obviously that will only improve. Okay, so that's the idea behind MyShake. We've had some pretty exciting year, to be honest, in terms of rolling out a new version of MyShake, the MyShake app, and starting to deliver early warning. So there are multiple components to the app. The first is early warning. I'm going to talk in more detail about that. But what we also do is we have to think about the user. We have to give the user who's putting it on their phone as many things that are useful to them as possible if we want them to download the app and to maintain the app, to keep the app on their phone as they move from phone to phone. So the other features are we allow people to report what they experienced after an earthquake. And we really focused not just on the seismology classic of what was the intensity of ground shaking you experienced, but also having people report the damage that they can see. And a future goal is to actually allow people to also provide photos, which kind of overlaps very much with some of the work going on here at PIA. Of course, there's basic safety information, and there's basic earthquake information from around the world. So those are the components that you'll find in the MyShake app today. So we released the app last summer, but then the really big release was when we started to use the app to deliver alerts. And I'll talk about where the alerts are coming from in a moment, but we were very lucky to get the governor's support for this. That makes a big deal. When you want to get people to download the app, you obviously need to have as much publicity associated with it as possible. So on the anniversary of the Loma Prieta earthquake, October the 17th last year, the early warning was officially turned on, and the governor announced it himself and encouraged everybody to download the app, which of course is exactly what we needed. So what does the alert look like? So the alert pops up on the phone, and this is what it sounds like.
Earthquake. Drop cover hold on. Shaking expected.
So it's very simple. We're talking about a few seconds, few tens of seconds warning. And so of course there has to be the audible notification because phones are in people's pockets, bags, etc. And then more information as you click through it. So that's what's built into the app. Now, the source of the alerts right now is not the MyShake phones themselves. The source of the alerts is the Shake Alert system, which of course has been under development and spearheaded by the US Geologic Survey, but in collaboration with Berkeley, Caltech, University of Oregon, University of Washington, and a variety of other groups for the last decade or so. And so Shake Alert is the source right now. Shake Alert is available, it's sort of been gradually rolling out over the last few years. It covers Oregon, Washington, as well as California. The system was officially open for business a little over a year in October of 2018 for technical users. And then in this October, as you just heard, it became publicly available in California through the MyShake app. And there is a plan to make it publicly available, the alerts publicly available in Washington and Oregon later this year as well. So that's the status of Shake Alert. So who can use earthquake early warning? This is one of the things that Greg asked me to touch on. What are the applications of earthquake early warning? I think the application that really drove the development, the sort of case use that finally justified the expenditure needed to build this Shake Alert earthquake early warning system was for personal preparedness. And it came from observations of injuries in Loma Prieta and Northridge earthquake, that more than 50% of the injuries were caused by people falling over or things falling on people. Very straightforward things to prevent if people take basic protective measures. And so the concept is simple. If everybody receives a few seconds of warning, and if everybody then takes action to protect themselves, then you can halve the number of injuries in an earthquake. And that is the cost benefit that really led to the justification of developing the earthquake early warning system. And the estimated savings of this are pretty significant. But then the other applications, which are perhaps of more interest to this community, are automated control. We already heard about the fact that BART uses the earthquake early warning system. Actually, I was on BART on my way home from a Cal game one weekend when the trains actually stopped because of an earthquake, because of the early warning system. It was pretty interesting to watch the reaction of everybody else on the train to the earthquake. The most amusing being a group of tourists who were stood right next to me who were like, wow, this is great. We've seen Yosemite, we've seen San Francisco, and now we've been in an earthquake. It was actually a magnitude 3.5 earthquake, but BART was taking a sort of very prudent approach, and whenever an alert comes out for even the smallest earthquakes, they slow and stop the trains, which I guess is what led to the project that you heard about earlier. Okay, so automated control, isolating hazardous machinery and hazardous chemicals, data security, and then situation awareness, those kinds of situations. So those are the broad concepts, but I thought it'd be useful to put up a list of the actual applications that are using earthquake early warning right now. So this is listing some of them that you already heard about, the BART, LA Metro also. Water companies, a lot of water supply systems are starting to use early warning to open and close valves, basically safeguard water supplies after an earthquake. Firehouses to be ready, an example of a condominium, so basically alerting people in the building to protect themselves, the same thing that you can do personally with the MyShake app. Hospitals, things like that. There's a group of sort of small startups and some slightly bigger equipment providers that are starting to link earthquake early warning signals to their operations from sort of actuator alerting kind of capabilities, engineering control and things like that. So we're obviously just at the outset, right? The early warning capability has only been available for a year or so at this point, and so people are really just starting to think about how they can use a few seconds, a few tens of seconds to reduce the impact of the earthquake at this point. Okay, so that's Shake Alert. And so Shake Alert is using the traditional seismic network to detect the earthquake, generate an alert, and then MyShake is just one of the pathways that are delivering that alert. So I want to sort of switch gears a little bit now and talk about MyShake in its own right, so MyShake's ability to detect earthquakes and what we might be able to do with that kind of information. So the way that MyShake works is that we want to detect earthquakes on your phone. So I'm not going to go and buy 1,000 phones and put them in buildings to record earthquakes. That's far too expensive. The real benefit is if I can use your phone to detect an earthquake, then potentially, of course, we could have millions, tens of millions of devices, both detecting earthquakes and also recording the response of the environment around us to those earthquakes. So that's the goal, that's the distributed sensing network goal of MyShake. So we do that by having people download the app, like hopefully you all will. And then the app, when you plug it into power, it goes into monitoring mode and to see if it detects an earthquake. When it detects an earthquake, it sends that to our back-end server. And so we can then use that information to provide real-time information about earthquakes. In the future, hopefully we'll be able to generate our own earthquake early warning alerts just based on phones. But also when it triggers, it records 5 minutes worth of data. And that data then gets uploaded to our archive when your phone is next attached to Wi-Fi, and that goes into the archive. And so that's the kind of research archive that we're just starting to build that I think has real potential to harness in terms of experiencing or understanding, as I say, how the environment around us is actually responding to earthquakes. I always have to show this slide. This is just the coolest thing, I think. This is the brains that makes MyShake possible. This is how is it possible with a reasonable degree of accuracy to detect when your phone is experiencing earthquake shaking as opposed to all of the other motions that your phone experiences. And this is using a machine learning approach to classify ground shaking. And we can essentially, when your phone shakes, and when we look at a 2-second window of data, we can determine whether it's earthquake shaking or not with about a 90% accuracy. So this is on a single phone. And then, of course, if a single phone thinks it sees an earthquake, it can send that information to our back-end server, and we can verify that that was indeed an earthquake very rapidly, and that provides for the real-time aspects of earthquake monitoring. Okay, I'm going to skip over this one. The first version of MyShake was launched back in 2016, and that was much more of a global launch. This shows you a map of distribution of downloads of the first version of MyShake. Over 300,000 people downloaded the app over the course of the 2-year period, and it really was a global distribution. So again, this gets to the point that once we can do this, once we can harness people's private phones, the potential in terms of the data set we can generate is really quite remarkable. I'm showing this pre-MyShake 2.0 because, of course, when we had the MyShake 2.0 release, the focus was very much on delivering earthquake early warning, which was just in California. So the MyShake 2.0 release has now added about 500,000 downloads, and about 400,000 of those, though, are in California. So it's very densely concentrated in California. So let's do the seismology part first, the earthquake detection part. So this is real data from MyShake. This is MyShake phones across Southern California detecting the Borrego Springs earthquake, magnitude 5 earthquake that occurred in just south of Palm Springs, you can see here. So all of the dots are the phones that were in monitoring mode. So not only did they have the app downloaded, obviously, but they were also in monitoring mode at the time of this earthquake. And when they turn orange is when an individual phone, it obviously moved, and then the phone recognized it was earthquake type shaking and sent the message to our back-end server. And so you can see that the vast majority of the phones that were in monitoring mode in Palm Springs recognized that it was earthquake ground shaking. As you move further and further away from the event into LA, you can see the fraction of phones that detected it obviously reduces because the amplitude of the ground motion is reducing. But this is only a magnitude 5.2 earthquake. So this was actually what we thought at the time was our lower bound for the earthquakes we could detect to magnitude 5. We can actually detect much smaller earthquakes. And then we can put on top of here an alerting layer, so we can then run a process on our backend server to detect the earthquake and generate a warning. And you can see this is now a simulation. So we're using the real data for detection and then running our alert algorithm after the fact. But this could generate an alert that could be pushed out to phones across Southern California. What's more interesting is to think about how this might work in other parts of the world, and we built a simulation platform based on the performance we've seen for the existing MyShake network. I run this simulation for the recent earthquake in Indonesia, close to Palu. This is what it looks like. That's when we would generate a warning, and so we would actually be able to generate a warning in this simulation before the earthquake shaking even reached Palu. So this is just to illustrate that there's some real potential here to harness phones using this MyShake approach in order to provide earthquake early warning in many places around the world. And then lastly, I just want to finish by saying it has occurred to us that this information could be used to monitor buildings as well, but we're really only just getting started in understanding what we can do. I'm going to show you a couple of plots that I'm almost embarrassed to show to this community because we really only are just starting to understand this ourselves. But this is work done by a student at the Berkeley Seismolab, Serena Patel, and with Salim Gunay, who's here from PIA, who's been helping us out. It's been much appreciated. But again, it's about using, this is the current density of MyShake phones across the Bay Area. And so these are all in 25 kilometer square, sort of 5 kilometer by 5 kilometer cells, but there are thousands of phones with the MyShake app that in the next earthquake, when triggered by that shaking, will record 5 minutes worth of ground shaking. So you can kind of see the potential. We've been experimenting with how much information we can get out of the cell phone type recordings. Of course, the quality of the sensors is not as good as the traditional networks that we're used to. And so this is an example where we've taken data from a traditional network, a sensor, and we've added noise to it that's similar to a phone. So that's the difference. The traditional data is the higher quality data, of course, the purple color. And then when we added the phone noise, that's the teal color. And then when you just determine the modal frequency for the building, we can do just as good a job with the MyShake type data as we can with the traditional data. So this is sort of showing us that we can start to extract parameters about building performance from the MyShake data, but we have a long way to go. The MyShake project has a long way to go to understand how this can be useful to your community. This is one example from actual MyShake data doing exactly the same thing. Again, just to illustrate that this is possible, but this is as far as we've gotten. Okay, so there's clearly a lot more that we can be doing this with the idea that we could potentially be monitoring the built environment in entire cities based on people taking the phones. I'll point out, you also don't need the owner's permission to do this, right? The building owner's permission. You just need somebody who lives or works in the building to decide that they want to know what the structural integrity of their building might look like. So that opens interesting possibilities. But to do this, we obviously need many, many more downloads. And so I'm going to finish by, we're very fortunate that we have some help in reaching that goal, and I'm going to let him tell you that himself. Oh, maybe I am, maybe I'm not. Okay, well this clearly isn't going to work. Oh, there we go.
So I just finished a press conference right here. We sighted the old Bay Bridge here on the Oakland side of the San Francisco Bay. 30 years ago, on this day, a portion of this Bay Bridge collapsed in a moment where I was living in the Marina District in San Francisco, now a week away. I remember like it was yesterday. 3 decades later, proud to announce that we finally have an early earthquake warning system that now is operational. And we're encouraging people to download the MyShake app. Our goal is to get 4 million people to download this app by the end of 2020. If we do so, we will have the most comprehensive, most, I think, technologically forward earthquake warning, early warning system of this type anywhere in the world. Mexico and Japan have versions of this, but no one, if we're able to get these apps downloaded, will have the technology in place that will save lives that we will here in California. Download the MyShake app. Please do so. Let's be prepared for the next big one.
So that's great. He wants everybody to download the app so they get early warning. But if with his sort of push behind this, just imagine that we have 4 million sensors across California for the next earthquake and what we could do with that data. So what we're trying to do here, this is my last slide, just sort of to wrap up, is we're sort of trying to build a system here where we're really connecting what we're doing in science, what you're doing in engineering, with sort of societal needs. And so we're hoping to build this virtuous circle between the scientific discovery, the reduction of hazard, user applications, in this case earthquake early warning, citizen science, so it's about engaging the community in the earthquake hazards as well as about providing them with actual information. And as we go around this, you can see where the various pieces I've talked about fit into this, but I very much hope that the engineering community also would be part of this circle, and so that's part of the reason I'm here. All right, thank you very much.